Hello, I'm Susie. My teammates and me will walk you through the process and outcome of the Project 2 in the next 5 minutes. Given a dataset of home equity line of credit applications with 32 variables and one predictor, we're trying to develop an interpredictable predictive model to evaluate its risks and an interactive interface that can help sales representatives in a bank or credit card company decide on accepting or rejecting applications. Models we've been tested are like GBM, SVM, logistic regression, and random forest. Next, we'll successively talk about descriptive model, explanation of prediction, and things we learned. Let's welcome Neil to share more information about our models.
Thank you, Susie. To conduct an accurate machine learning model, I did some data preprocessing work for the project. From the data dictionary, we find that for each feature, there are -7, -8, -9, denoting 3 types of missing values. So I convert them into dummies to capture that information. Then I remove them and change them to the mean of the rest of the data. Besides that, I convert those 2 variables on the slides into dummy as well. By doing the data preprocessing, it gave us more features to analyze when establishing model. So I will invite my friend Jawan to introduce our model.
Thank you, Neil. For modeling part, first, we wrote a function for model tuning. Using grandsearch CV for each hyperparameter of each model, we passed in a bunch of possible values, compared the ROC and AUC score, and chose the best parameters for each model. Then we tried to select the best model for our prediction, so we created another function. In this function, we found the optimal threshold, got accuracy over test set for each model, and plotted ROC curve for them. Finally, we got the highest accuracy on random forest, which is 74%, but light GBM model gave us the highest AUC, so we chose it as our final model. Then, let me invite my friend Chris to introduce our website.
Thank you, Jawan. After tuning hyperparameter and select the best model, we save this model and deploy them on GitHub and Heroku. By doing so, any user can directly access the web app and use our machine learning model via web browser. Now, let me open the website. In our web app, we have 3 pages: models, data, and documents. In the first page, user can choose the machine learning models to use, select feature value, and see the prediction for the risk of default. User can choose among light gradient boosting model, logistic regression, random forest, and support vector machine. In addition, user can select to display more information about the models, including the AUC score, the accuracy, and the top 5 important features. In the data page, user can download the data and check the data dictionary. In the last pages, we provide user the link to the full report, the notebook, and the GitHub. In addition, we also have some summary for the project in this page. Next, my friend Pin will share our lesson that we learned from this project.
Thank you, Chris. So what lessons do we learn through this project process? First of all, you should be careful about your data. That means you have to read dictionary carefully and identify where the issues are. For example, in this case, we initially ignored the negative values, which means now. You have to make them dummy values. We should also be clear about the problem so as to build models based on it. As we apply our models to solve problems, we have to keep in mind that all we have done should deliver business values. For example, in this case, it is not enough to only show the risk. We have to tell the users what had contributed most to this result. It brings value to the non-tech users. To summarize, we succeed in building the model and giving intuitive explanations to the users through the web interface. Our process includes pre-processing, modeling, and web interface building. The approach has the following key advantages. There is detailed information in our report. If you have further questions, feel free to contact us. Thanks for listening.